And welcome to today's Build with Mercury technical workshop session. There is hosted by the Protocol Labs and Decentralized team today. So without further ado, let me invite the first speaker that we have for today, Yusef Napora, who is a software engineer at Protocol Labs. And today he will bring you through a 45-minute session to talk more on the NFT storage. Yusef, please.
Hi, thank you so much. It's great to be here. Let me go ahead and share my screen and get started. So, yeah, I'm Yusef, and I am an engineer at Protocol Labs. We make some decentralized file sharing and storage technologies that you probably heard about in the course of this hackathon. So IPFS and Filecoin are both Protocol Labs creations. And today I'm here to talk about a service that we stood up earlier this year called NFT.storage and sort of get into why we built it, what actually it is, and then how you can use it. So my interest in NFTs, it really did start earlier this year, although again, I was sort of aware of them, but they kind of obviously blew up in the public consciousness, beginning of this year, sort of. And we at Protocol Labs were really happy to find that people were using IPFS to link their NFTs to off-chain data, because a lot of NFTs are a mix of both information stored in a blockchain and information that lives off-chain, and the link between them can happen in a number of ways. So, for example, like NBA Top Shot, when what's recorded on the blockchain is a moment ID, just a unique identifier for a particular NFT. And then to render the actual moment, the NBA Top Shot site will correlate that with a video clip and so on. So, or another popular alternative is just to store a HTTP link inside the blockchain record, and from there go to some image or video asset that lives elsewhere. But there's the option of also using IPFS, which is similar to HTTP in that your content lives elsewhere, but it has some really cool features that make it a better fit for NFTs, in our opinion, than a sort of traditional HTTP link, especially if you're optimizing for decentralization, like in the sense of like, you would like all of the content of the NFT to be both like available to anybody so that it can be sort of like truly owned by the recipient of the NFT, and also not really dependent on any single service or server. So that's not everybody that's building NFT applications has those particular goals, but those are the kind of goals that are in the wheelhouse of Protocol Labs, is to sort of encourage this kind of decentralization and also provide the tools to make it easy for people to do it. So that's kind of part of the motivation for NFT storage. And as we got into the NFT space and people were using IPFS, we sort of realized that there were some friction points, right? So before NFT storage existed, the people were using IPFS to store their NFTs, and there were some issues with that we think the NFT storage can address, and especially the integration of Filecoin. So I'm going to briefly talk about how IPFS alone fits into the mix, and then talk about how Filecoin adds to the equation and how you can leverage the whole thing with NFT storage. So with IPFS, right, it is the interplanetary file system, although at the moment it is still intraplanetary, I suppose. It's been around for a few years, and the way it works is you give each piece of content a unique identifier called a content ID. And this ID is derived from the content. So it goes through a cryptographic hash function, and then it spits out this opaque string of seeming gibberish that will always be produced if you feed the same content into the IPFS hashing algorithm. So the real power of this is that you don't need to split the world into domains and namespaces and servers and things like that. Every single piece of content in the world can be addressed with this one naming system. So it also gives you a pretty interesting property of nobody can alter the data without it being immediately obvious. So if I send a request out for this particular content ID and somebody gives me back some other piece of data, I can instantly tell that this is not a match, and I can just reject it and say something was wrong. Maybe like a bit got flipped in transit, or somebody has altered the data intentionally or something like that. So with IPFS, that can't really happen. Like the key is directly tied to the value. And that's kind of an interesting property because it means that if I have a link in, for example, blockchain, and once it's written, I can't change the link, right? But if the link is an HTTP link, the value on the other end of the link could change at any time, right? There's no way to guarantee that an HTTP server is going to return the same response tomorrow that it did today. And as a result, it kind of makes the durability of the NFT record a little bit shaky, because while the record of ownership itself is permanent, it depends upon this link to an external system, and the link itself is not especially permanent or static. So with IPFS, you do get these sort of eternal links, like an IPFS CID will always point to this one piece of content. And what's kind of cool is that you don't have to get it from any particular place. So here, one IPFS node is saying, hey, does anybody have this content ID? And this person, this node over here does. So it's going to respond with the content in question and just send it over the wire. And if it's an especially large piece of content, the requesting node might broadcast, hey, who has this chunk and this chunk and this chunk, and like all the little pieces of the file that I need. And those could come from anywhere, and potentially multiple different nodes could be throwing data at you all at once. So in some ways, it can be more efficient than HTTP, depending on how popular the content is and how widely distributed it is throughout the network. So now that this person has requested the content, it can serve it to anybody else. And so this third node here can ask, again, it just broadcasts a request to everybody who's got my stuff. And now both of these nodes are able to respond and return the goods. And that's pretty cool. And it means that the original node could actually disappear, and it's not really a big deal because these other guys here have the content and are primed to respond to those requests. But then there was a caveat, and the caveat is that all the nodes could potentially go away. And in that case, the content will not resolve. And that's kind of a problem for IPFS alone, because IPFS is a permissionless peer-to-peer system, and there's no constraint in place that you have to stay online forever. It's sort of a, everybody is chipping in to share and distribute this information. So it is possible that some piece of content could disappear from IPFS if nobody's actually online holding it. And then the second caveat is this thing called garbage collection, where when the data is distributed throughout the network, those copies, like when I fetch a piece of content and then I'm going to serve it to somebody else, those are temporary copies that could potentially disappear if my disk gets full. And you can prevent that by pinning content and saying, hey, my IPFS node, please remember this particular piece of content. Even if you get a little short on disk space, please don't clear it out. So that's pretty cool. And but those two caveats are why a lot of the IPFS usage was going through third-party services, like a pinning service who would host your content for you, pin it, and keep it online forever. And that, or as long as your relationship with them continues. And that's cool. Not everybody wants to run an IPFS node. And yeah, but the lack of sort of awareness about these caveats was kind of an issue for us, because we were seeing people using IPFS to store their NFTs, but not necessarily understanding this whole pinning process and the idea that your content doesn't live on IPFS forever by default. So we wanted to reduce the friction to getting NFT data into IPFS, and also provide a long-term durable data storage solution for people that are using this IPFS that is also, decentralized and aligned with our mission of preserving humanity's data for perpetuity, I guess. So it's kind of a broad mission, but we're we're getting there. So nft.storage is one of our answers for how this is going to work going forward. So it is a place where you can store your NFT data. It is decentralized. So IPFS and Filecoin are the underlying technologies here for not just like distributing the data, but also preserving it for long term. And it goes some way towards solving this permanence problem, where like your data can be on IPFS in this peer-to-peer decentralized network, but you also have this kind of long-term guarantee that on the Filecoin layer, that data is not going anywhere. So I'm going to talk a little bit about how the process works and what the experience of using nft.storage looks like, and then I'll fire up a terminal and we can hack away at it a little bit so you can see what using it is like. So you just upload your data to NFT storage, and then NFT storage will add it to an IPFS cluster and make it available on IPFS right away. But then behind the scenes, NFT storage is going to negotiate deals to store your data with a Filecoin storage provider, actually several Filecoin storage providers. So the way this works is the Filecoin network will incentivize these storage providers, to store the data by rewarding them with Filecoins. So you make like at a high level, the way the Filecoin process works is you, the storage client, make a deal with the storage provider that says, I have some data for you, please store it for this amount of time. And they commit to that. And then the deal is recorded in the Filecoin blockchain. And over time, that storage provider will be challenged to say, please prove to me that you are storing a unique copy of this data. And that process is fairly involved, and you can read all about it on this Filecoin specs site. But the upshot as a user is that you can trust that for the duration of the deal, if the data were to disappear, the storage provider would be essentially punished for it. Like they would lose a significant amount of Filecoin collateral, and also it will be rewarded if they do keep it. So there's this strong incentive for them to preserve your data, and you kind of get that peace of mind that somebody out there has your stuff. And in the meantime, people can retrieve your data through IPFS and get that kind of decentralized and location independent linking property that is such a nice fit for NFTs. And you also get this, long-term assurance. And one of the reasons it's good is that if NFT storage were to go away, your data would still, of course, be on IPFS. But if all the IPFS peers who ever fetched your data went away, those Filecoin storage providers will still have it, and they'll still be able to provide it to anybody who really needs it. So you, the NFT creator, are not dependent on Protocol Labs for the continued accessibility of your data. Even if everything we've built, were to crumble into dust, you could run your own IPFS nodes or retrieve the data from Filecoin and so on, and re-provide it at exactly the same location as before, without having to rewrite any links. Whereas let's say if I had uploaded my data to a web server and just recorded the HTTP link, then if that web server were to disappear, there's really no recourse for the original owner of the NFT to, make that link work again, because they just don't control the domain. So it's kind of an interesting setup where now, like, you have this sort of big pool of available storage in Filecoin, and the data can be requested by this content ID that is not tied to a particular place that it's being stored. So this gives you a lot of flexibility, and allows you to like keep the link permanent, but also keep the actual location that the data is stored flexible. So we think that's a pretty interesting property, and it's kind of useful for the NFT use case here. So this is what the site looks like. It is nft.storage. It's pretty easy to remember, and you should check it out. It's pretty simple. We have an HTTP API, and yeah, you upload a file, you can see what you've stored, you can get some information about files that you have previously stored, and you can sort of check if a particular IPFS content ID has been submitted to NFT storage. This schema is wrapped up and packaged nicely in a JavaScript client library that I'll show you in a minute. This is probably the simplest way to interact with NFT storage, but we do also have client libraries in several other languages, such as Python, Go, and Kotlin, everything else. Those are generated from an open API schema, and they all basically follow the same format. So if you, if you watch me use the JavaScript client, you'll understand the principles of all the others as well. So these are the various clients that you can find on our GitHub, the nft.storage organization. And I'm just gonna take a few minutes to show you what NFT storage looks like. So here's the site. I'm gonna log in, and I will log in with GitHub since I'm already signed in with GitHub here. You can also enter your email and it'll send you a little magic link to click on. Oh, and before I get into this, I feel like I totally spaced out on one of the most compelling arguments for using NFT storage, which is that it's totally free to use. And it's actually the storage space on Filecoin is free for us at Protocol Labs, because the value of real user data to Filecoin storage providers is actually quite high. They get increased block rewards for storing real data. So by uploading data through NFT storage, you're actually giving a valuable commodity to these storage providers, and they're incentivized to store your data even though you don't actually have to pay anything. So that's kind of nice. So anyway, here I am back logged into my files page. I can upload here, just pick a file. This little is car box is kind of interesting. I'm going to talk about the car files in a minute. This is a way to upload already sort of formatted IPFS data, and it will let you upload really large files that would otherwise hit a size limit with the HTTP API. So we'll talk about that in just a second. But generally speaking, if you're just uploading regular files, you could hit this button, pick a file, and you're good to go. But most people probably won't be uploading every single NFT by clicking on a button on the website. So we imagine you'll probably be using a client library or something like this. So to use the client, you'll need an API key, and make a new one here. Let's call this Mercury. Okay. And now I have this key that will let me authorize my client. So here I am, I got an empty directory. I have some images that we can toss onto NFT storage later. But we're just gonna make a new NPM project. So in it, and just accept all the defaults and stuff. And then I'm gonna install nft.storage client library. I'll pull everything down. And once I have that, we'll be able to write a little JavaScript program to add stuff to NFT storage. And okay, so there we go. And I'm gonna just page over to an editor here and make a new file called index.js. And let's see, presentation mode so you guys can see a little better. And there we go. So actually, let me call this index.mjs, because that will let me use the import syntax that I kind of prefer for JavaScript. So now I can say, well, before I get started coding, why don't we take a look at the docs so I know what I'm doing. The NFT storage doc site, this will give you, this is the JavaScript client library reference docs. So first you install it, and then we're going to import some stuff. NFT storage, and if you're on Node.js, you won't have the file object in the global scope. So that's sort of a browser thing, but NFT storage includes a file compatible interface. So you can import file from the NFT storage package as well. And then you'll make a client with your token, and you can call any of the methods there. So let's grab the imports from the doc site, and I'll toss it in here. And even though this is a, bad idea in general, I'm just going to hard code my token, paste it in here. Like managing your tokens is like one of the tricky bits, or you want to store it somewhere safe. In a real project, please don't check it into your source code. It's better to read it from an environment variable or some other external configuration so that you can easily replace your tokens and they're not, just sitting on GitHub for anybody to grab. But for now, we'll just say, hey, we're all friends here. Right, so back here, I'm going to grab my key and paste it in. So now I can say client equals new NFT storage token. So this is going to let me upload and call the API method and so on. So let's make a function that will store an image with NFT storage. And pass it the path to a file. Okay. So we're gonna have to read this file data in, and then we'll pass it into NFT storage. There's actually we can either use Node.js's like built-in FS module to read in the file data and construct a file object, or there's a helper library that we use in one of our other projects, web3.storage, called get files from path. So I'm going to actually use that, but let's see. I'll show you the repo here. Files from path. Oops. Oh, there it is. Sorry. There we go. So this guy is just a little helper for reading from the file system into that file object format. So I'm going to install this as well. It's bundled in with Web3 storage, but you got to bring it yourself for nft.storage. Files from path. So now I can say import get files from path from files from path. So now you give me the file name, and I can just say const files equals await get files from path file name. That actually returns an array of files because this will recursively grab all the files in a directory. If you want to upload a bunch of stuff. We'll probably just point it at a single file for simplicity, but yeah. So then once we have that, there's a few different things we can use to get this stuff into IPFS. So the main example that you'll see, the first thing you see is this client.store method. This is probably, well, it's usually what I recommend everybody use. But if you're using Flow, maybe the conversation is a little bit more nuanced, because this store method will accept an object that is structured in the same shape as the Ethereum ERC 1155 metadata format. There's nothing like Ethereum specific about this. You can definitely use it with Flow, and might as well. But if you have already mapped out a metadata scheme for your Flow contract, then you can use that instead. That's totally fine. I think there's not the same standardization of metadata in the Flow NFT world that there is in the Ethereum world at this point, as far as I can tell. It's sort of contract specific. So you're going to have to sort of decide for yourself what metadata makes sense for my contract, what of that metadata belongs on chain versus off chain, and so on. So if you want to have, I mean, that said, I think that using this store method is still probably a good idea. That like even if you do also store metadata on chain in your Cadence contract, just because then anybody can grab it and see this without interacting with the blockchain. So it's up to you how you want to do this. But the so the alternative to client.store is store blob, which just takes a file or blob object of binary data and puts it onto IPFS and Filecoin as is without any metadata manipulation that's the store method would do. And then there's also store car, which is to store those content archives I was alluding to earlier. So we'll start with store and just go through what that looks like. So it accepts, as I said, an object, and it has to have these properties: name, description, image, and then I believe this one is optional because this is just for arbitrary key value metadata that you want to attach to your NFT. And what's kind of cool about the store method is that it has this sort of inline recursive thing where essentially if I have a field in my metadata that is a file or blob object, the NFT storage service is going to add this file to IPFS, and then in the metadata for the NFT, it's going to replace the file object with a link to the file in the form of an IPFS URI, which is a string that's like IPFS : / the content ID, and optionally a human readable path as well. So this sort of thing where you can just pass like a big JavaScript object that has these embedded files, and it will get sort of linkified for you. That happens with the store method, but does not happen with store blob and so on. So it sort of depends on your use case, which of those you're going to use. If you're already storing your metadata in Cadence and you just want to link out to, say, an image or a movie or something like that, you might not want to use store. Maybe you just use store blob. So that's kind of what's up there. For this example, we'll say, let's see. So files, get files from path. I'm gonna actually, let's just store a single file just to make this simpler. So files length not equal 1 expected single file, and then we're just going to say, okay, files 0. Okay, so now we have a file, and we're going to call that store method and toss in some metadata. So await client.store. All right. So name, and this is something like we're going to hard code in some metadata here, but you would obviously want to have every piece of this be user submitted or whatever. This is part of your NFT creation flow, but we're just going to say hello Mercury and description NFT storage example, and image. We'll just assume that this image, or that the file we're given is the image that is going to be stored. And there we go. So what this is going to do is take it's going to send everything off to nft.storage service. The NFT storage service will first store the file. Then we'll end up with a JSON object that's stored in IPFS that has these properties, and the image will be a link to the file, or the image field will be linked to the file. And then I'm just going to console log the metadata object so we can see everything that's returned. And then we'll have a main function. Say that it's going to be the, well, let's, process arg v3. It'll be the first command line object. And then first command line argument. So then we have a file name, and we're just going to say await store image file name. And then call the main function. Okay, so that should hopefully get us something we can call with node. If I say node index.mjs and give it say images slash this thing. Oh no. See. Storing undefined. I think my argument reading my command line argument stuff is wrong. I think this is actually supposed to be argv2. Image must be file, blob or file object. Sorry about that. There is a parameter to, yes. The get file, so this is something I forgot about. The nft.storage image field, it really wants you to submit an actual image. And it will check the MIME type of the object. So I am actually going to say new file, give it the original file as input, file name, and then the options here, we're going to say type. Let's see, image slash GIF. Yeah, so that's one caveat, is that the store method is a little bit picky about what kind of data it will accept, whereas store blob will take anything you give it. So hopefully this will give us some, hey, it's working. No, it's not working. Oh no. Expect a response with 2 entries. Got 3 instead. Well, I'm not sure what that's about, guys. Let's see. All right. There seems to be a problem with the get files from path helper, so we're going to try and use the Node.js stuff instead. So. Okay. So we're going to say content equals await fs.read file name. Yeah. And then we're going to say make a new file from this content, and we'll try that. All right, so lesson learned, get files from path is maybe not live demo friendly as I hoped. This will probably take longer for the bandwidth is awful. So when I'm doing Zoom things and uploading things, I tend to get in trouble. But in a minute or so, it'll be up on NFT storage. And then from there, it will go into IPFS and Filecoin. And we'll see once this is finished, it will return a metadata URL and some other properties of the object. While it's storing, I'm gonna just go and over to the docs so we can take a look at those other. Oh, somebody's asking. Sorry, before I move on, somebody's asking in the chat, like, what's the best and worst case scenario for upload time? So, I mean, for me, like I said, my bandwidth here is atrocious. My bottleneck is the connection between me and nft.storage. If you're either the super fast connection to nft.storage, you should get the file there with much quicker than I would. Then it'll take just a few seconds for the content to be retrievable on IPFS. And then following that, it takes about around 8 to 24 hours for the data to be aggregated into a deal. the way the deal making works is that we'll batch up lots of small pieces of data and then submit them all in one big chunk to a Filecoin provider. So it might not end up on the Filecoin blockchain right away, but within a few hours, it will be backed up for the long term on Filecoin. But basically, as soon as you get the response back from NFT storage, you can retrieve your stuff. So, oh no. All right, so clearly, I don't know, something's wrong here, and I feel kind of bad that I'm leading you guys astray. My my code is blowing up. All right, let's try, instead of using client.store, let's just try using store blob and see if maybe we'll have more luck with that one. So for that, we can just pass in our file object directly, since a file is also a blob. And then instead of a metadata object, store blob is just going to return a CID string, the content ID. So let's rename this variable. So again, apologies for things kind of falling apart in live demo mode here. In hindsight, I should have run through all this offline first. But I'm actually going to try a smaller image. Let's see what we see there. So like I said, store blob might actually be a better fit for some of you if you have like opinionated metadata choices already. If you do want to use the store method, please hit me up after this, and I will figure out exactly why this broke and come back to you with the guidance for how to do it. So, hey, there we go. This one worked. We have now a content ID string. So this image is now available on IPFS, and I can go to my web browser here and we'll make an IPFS gateway link for it. So if I paste in the CID and say .ipfs.dweb.link, that's going to go to an IPFS HTTP gateway, and it will pull the content from IPFS there. Sorry, it's loading a little bit slowly here, but that's cool. Back on the NFT storage doc site, I do want to talk a little bit about store car, because currently there is a 100 megabyte upload limit on the store and store blob endpoints. And this is just an artifact of the backend infrastructure that we use. But store car is kind of an interesting way to work around this. A car is a content archive, which is basically just a bunch of IPFS data that's already been chunked and formatted in IPFS format. And what's kind of cool about them is that you can take one big car file and split it into pieces, and then you could upload each of those pieces independently. And the backend is going to stitch them all back together into the original large file. So you can use this to submit like files of an arbitrary length. Pretty soon this isn't going to be necessary. The client library will do all the carring for you, but that's probably only going to make it to the JavaScript client. So even if, so once that does land, if you're using a different client, you'll still probably want to understand how car files work if you want to upload really large NFT assets. So creating a car file can be done with this helper tool called IPFS car. And this gives you either a JavaScript library that you can use or a little command line tool to pack files from your file system into a car file. And then if that car file is too big to fit into the 100 megabyte limit, you should look for this thing called car bytes. Car bytes, and yeah, NFT storage / car bytes is the repository here. This takes a big car and splits it into smaller pieces. If you do end up using this, I just want to call out that the variant that you want to use is this one called tree walk, where it's going to take the whole IPFS graph, walk through it, and then chunk it up into pieces that can be recombined into the original graph. So that's probably more like technical than you'll actually have to get, to. You probably won't have to use this. Like I said, if you have big files over 100 megabytes, this will help you out. and this is a way to get your data into IPFS. It's also, if you have a lot of IPFS experience and have already formatted your data in an IPFS compatible way, you can use this to just send it to us as is without having to reformat everything or anything like that. So that's cool. And then finally the store directory is just like store blob basically, but you can get a bunch of files and it will wrap them in an IPFS directory listing and store them all in one go. Oh, sorry, here's the thing we uploaded earlier, by the way. So this is now being served through the gateway. So nobody has to have IPFS installed to retrieve it. You can just view it on the web. If you do have IPFS, you could say like IPFS get this content ID. Yeah, so that's cool. And I do want to mention about, as I'm on this tangent about car files a little bit, there's a page on the Web3 storage docs, which is another very similar service that we run for arbitrary data that you want to store in IPFS and Filecoin that's not NFT related. But on the doc site there, we have a page about working with car files. So I want to call that out here because we don't have that yet for NFT storage. So if you are working with cars, you can go to docs.web3.storage and go to work with content archives. And all this stuff will be helpful for that, for NFT storage as well. Kind of goes through using the IPFS car stuff and all this more advanced IPLD usage and things like that. So yeah. All right, I think that's probably where I'm going to wrap it up and quit while I'm ahead, I guess, now that I got something to work. Thanks so much for guys. If you guys have questions, please drop them in chat.
Yep. Thank you, Yusuf. Before you go, there's just a couple of questions that people have actually put in on the Q&A. I think one of the question is to ask you if NFT storage is like Pinata.
In some ways, yeah. There are some differences. I mean, for one, obviously we don't charge anything for storage. The other is basically just like the underlying long-term storage technology. Like Pinata isn't yet persistent to Filecoin, although I think that is something that they're interested in doing as well. And we would love to see that, of course. Like the more of these like aggregation and deal making services that arise, the happier we'll be. So I think, fundamentally speaking, like they offer a similar value proposition. So it's like an interface into IPFS that offers this like sort of persistent storage story. I think Pinata, there's, I don't know, they offer a really good service and I think you should definitely consider using them. For NFTs, I think, it just sort of depends on what kind of relationship you want with the service. Like we're happy to provide this to everybody for free, but maybe you want like more hands-on support from the Pinata team, or you have like a special, like you want your data to be stored in a specific region or something like that. Like I feel like there's definitely reasons to choose Pinata versus NFT storage, but our goal in creating NFT storage wasn't really to like eat Pinata's lunch or anything. It was just to provide more options for people to, get their stuff into this whole decentralized storage ecosystem. So, I mean, obviously we're happy no matter what service you use, but yeah. Oh, let's see,
Okay.
please share. Oh yeah, somebody's asking for the links to the repository. So everything is on GitHub at NFT, sorry, the nft-storage, or sorry, the IPFS shipyard /nft.storage is the main nft.storage repository. And it's all the code for NFT storage is open source. So you can see how all the backend stuff works as well. Interested in that?
All right. The other question that actually popped up was to ask why the extension of that index file is actually .mjs.
Oh, right. So recently Node.js started supporting this import syntax, versus previously you'd have to say like require some package and then assign that value to a variable. And now instead you can do stuff like import NFT storage from NFT storage. This is called the ESM module syntax. Anyway, to use it with Node, like it's sort of supported by default in browsers now, but to use this syntax in Node, you can either end with a .mjs extension, or you can go into your package.json and add a field call that says type module, and then that will also enable that syntax. Otherwise, if you didn't do that and you just called it, this is just a regular JS file and you don't have type module, then instead of saying import, like let's rename this real quick to just .js. Oops. Yeah, if this is just a JS file and you don't have type module, this is going to give you a compiler error when you try to run it. So instead, you'd have to say const NFT storage, whatever, equals require NFT storage. And but I prefer using the module syntax just because it's the same in browsers and in Node. So it's just one less difference you have to keep track of.